Now let us go over some of the important and interesting properties related to ellipse and its tangent and normal. Okay, so we will go through all the properties one by one. First is the sum of focal distances of any point on an ellipse is always constant. So we have seen this even in the definition of the ellipse. It's one of the defining characteristic of the ellipse. So if we consider some ellipse with its two foci, and let's consider some general point P on it. So the sum of its distances from the two foci is always constant, no matter which point we consider. So if you consider any point on the ellipse, the sum of the focal distances is always constant, and in fact that is equal to nothing but 2a in case we consider the horizontal ellipse. And we know that 2a represents the length of major axis of that particular ellipse. So that's the first property. Let's go ahead to the next one. The length of semilatus rectum is the harmonic mean of the lengths of the two parts of any focal chord of the ellipse made by the focus. So let's understand what this property is. Suppose we consider some ellipse, okay, and these are the two foci. It's the major axis. Now latus rectum is the segment passing through the focus and perpendicular to the major axis, correct? So let's call that as LL dash, and the focus is S. Now let's consider any focal chord, that means the chord that passes through the focus. Okay. So clearly that will get divided by the focus. Let's call the endpoints of the chord as A and B. So therefore AS and BS are the two parts of the focal chord made by the focus, and LS represents the semilatus rectum, that is a half of the latus rectum. So what this property is saying is the length of semilatus rectum, that is LS, is the harmonic mean of the lengths AS and BS. Okay, so that is the meaning of this property. Now by harmonic mean we know the formula for harmonic mean, what it is. LS, that is the semilatus rectum, is the harmonic mean of AS and BS. So clearly it is 2 times AS into BS whole upon AS plus BS, right, which is the denominator is nothing but the length AB itself, the length of the focal chord. Alright. Let's see the next one. The circle drawn on any focal length of an ellipse as diameter touches its auxiliary circle. Okay, so let's first consider some ellipse, and let us consider its auxiliary circle also. This is the auxiliary circle. Now if we consider, say, the two foci S and S dash. Okay. Now let's consider some point on the ellipse. So let's consider this particular point on the ellipse, say P. Okay. By the focal length of P we mean it's the distance PS or the segment PS or PS dash here. Right. If we draw a circle considering PS dash as the diameter, okay, then that particular circle will touch the auxiliary circle. Okay, that is what this property is saying. Okay, no matter where the point P lies, the circle drawn considering its focal length as a diameter will always touch the auxiliary circle of the ellipse. Okay, let us go ahead to the next property. Now here it says that the locus of feet of perpendiculars drawn from foci to any tangent of an ellipse is its auxiliary circle, and the product of lengths of the perpendiculars on any tangent is B square. Okay. Now let's understand one by one. Let's consider the first part. Locus of feet of perpendiculars drawn from foci to any tangent is the auxiliary circle. So that means, first of all, let us consider some ellipse. Okay. This is the ellipse. Okay. These are the foci, the two foci. What the property says is, if we consider any tangent, so let's consider some tangent to the ellipse. Okay. Now let's consider the feet of the perpendiculars drawn from the tangent. Okay. So these are the feet of the perpendiculars drawn from the tangent. Okay, so consider the two blue points. Let's consider some other tangent now. Suppose we consider some other tangent like this, and from the foci we draw once again the two perpendiculars like this, and again I show their feet. Okay, so if we consider the locus of all these blue colored points, it will turn out that traces precisely the auxiliary circle of the ellipse. And the second property says that, the second part, the product of lengths of the perpendiculars on any tangent is b square. So therefore, if you consider the first tangent, the lengths, that is this length multiplied by this length, will be equal to b square. That is what this particular property is saying. So that is true for any tangent.